This is Chris and Jade. We have problem number 24 from the textbook. A shopper in a supermarket pushes a loaded cart with a horizontal force of 10 newtons. The cart has a mass of 30 kilograms. And the questions for this problem are split into two. The first one is how far will it move in 3 seconds from rest? And the second one is how far will it move in 3 seconds if the shopper places his 30 Newton child in the cart before he begins to push it.
For problem A, we know that Fn is equal to 294 newtons, which is also equal to the force of gravity, because they're equal when it is at... For problem A, we know that the force of gravity and the Fn are equal and are 294 newtons each. And from the problem, we can find that the Fa is 10 newtons in the x direction.
For problem A, the first thing we need to do is find the acceleration. So the equation we're going to use is Fa is equal to mass times acceleration. So we know that the applied force is 10 newtons, and we know that the mass is 30 kilograms, so we need to find acceleration. So then you divide both sides by 30. The 30 cancel out, so then acceleration equals 0.33 meters per second.
So the problem for letter A is how far does the cart move in 3 seconds from rest. So we're going to use the equation delta x equals VIT plus 1/2 AT squared. Since the cart starts at rest, VIT cancels out and goes to 0. So we have delta x equals 1/2. A we found to be 3.33, and t is given to us as 3 seconds, and that is squared. So using algebra, we have So the objective for letter A is to find the distance for how far the cart travels. So we're going to use the equation delta x equals VIT plus 1/2 AT squared. In the problem, it tells you that it starts from rest, so VI is going to equal 0, so that cancels out. So then we're left with 1/2 AT squared. Plugging in from what we found earlier, acceleration is 0.33 meters per second squared, and t is given to us in the problem as 3 seconds. So when you find delta x, you get 1.49 meters. And that is the full answer to A.
Okay, so for problem B was... okay.
For letter B, the question is how far will it move in the 3 seconds if the shopper places his 30 Newton child in the cart before he begins to push it. So for this part, we need to rethink our math. And the 30 Newton child, his weight has to be divided by 9.8 to get it in kilograms. And since we already know that the cart has a mass of 30 kilograms, we can take how many kilograms the child is and add the answer that we just got for a total new mass of 33.1 kilograms.
Okay, from problem B, oh my, what do I say? For problem B, we're going to use the equation to find acceleration, which is Fa equals mass times acceleration. So we know that the acceleration, oh my goodness, for problem B, we're going to use the equation to find acceleration, which is the force equals, for problem B, we're going to find the acceleration. In order to find the acceleration, we have to use the equation. The applied force is equal to mass times acceleration. So we know the applied force is 10 newtons, which is equal to our new mass of 33.1 acceleration. So we divide both sides by 33.1. 33.1 cancels out, so acceleration equals 0.302 meters per second squared.
So once again, for the final answer for B, we have to find the distance the cart is going to move, and we're going to use delta x equals bi t plus 1/2 at squared. And once again, it's moving from 0, and so we get delta x equals 1/2 at squared. Plugging in what we already have with the acceleration that we just found is 0.302 meters per second squared, and time is again 3 seconds. And delta x, once you multiply it out, is equal to 1.36 meters. The final answer to problem number 24. So the new free body diagram for letter B, the Fn and the Fg are equal, but they are now So the new free body diagram for letter B is the Fn and the Fg are still equal to each other and are 324 newtons. And the Fa is still 10 newtons. And the Fr is once again ignored.